In this video, we're going to start talking about evaluating polynomial functions. There are essentially two ways. We have the direct substitution method, which is the easier to understand process, but it generally takes a lot more time and effort. And then there's the synthetic substitution, which is a little bit more involved, but if you understand that process, it goes very, very quickly. Okay, so we are going to do the exact same question twice, once with direct substitution and once with synthetic substitution, so we should get the same answer. We are given a function that says evaluate when x equals 3. So traditionally, the direct substitution method says take 3 and then replace x with 3 every time that it showed up. Now we have to multiply this out. So immediately, I already kind of feel like this is not going to be a fun process. I know 3 to the 5th is 243. 3 to the 4th, that divided by 3 essentially, which is 81. 5 times 3 is 15, plus 10. 3 times 243, 729, minus 81, minus 15, plus 10. Just following my order of operations, 648 minus 15 plus 10. That's going to be 633 plus 10, which is 643 for my answer. That was just plugging in the number 3. That got real annoying real fast, and the number I plugged in wasn't very large. If I had to plug in a number like 7, which is still not a big number, this is going to be just ugly. So the synthetic substitution makes this process go faster, but we have to remember a few different things. So first, write all the coefficients of every degree term. So in this problem, we have 3x to the 5th minus 1x to the 4th plus 0x to the 3rd plus 0x squared minus 5x plus 10x to the 0 if you want to write it that way. You don't necessarily need to write that, but if you forget these two terms, your whole process is going to go upside down quickly, which is not great. So what I'm going to do is I'm going to write my coefficients: 3, negative 1, 0, 0, negative 5, positive 10. Okay. Then I'm going to put a little box over here to the left. I'm going to put a 3. This 3 is the 3 that I am evaluating. Okay. Now I'm going to make a little line here. Depending on where you look, if you Google something, if you look in the textbook, you talk to other teachers, you'll see a slightly different visual of this, but it's the exact same thing. So what I'm going to do is I'm going to take this first 3, and I'm just going to bring it down. Now I'm going to do the 3 that's highlighted green times the red 3 to give me a 9. I'm now just going to add that column together. Negative 1 plus 9 is 8. 3 times 8, the green 3 times that 8 is 24. 0 plus 24 is 24. 3 times 24 is 72. 0 plus 72 is 72. 3 times 72, the green 3 again, times 72 is 216. Add that with negative 5, you get 211. 3, the green 3 times 211 is 633, plus 10 is 643. There's nowhere left to go. This is my answer. Okay, so process-wise, the amount of work that we did spatially takes up about the same. But what we had to deal with in the direct substitution is we had to make sure we did all of our exponents correctly. Exponents are something that if you make even the smallest mistake on, your answer is going to get wildly different. All right, if you cube something when you're supposed to put it to the 4th or whatever, it can go bad really, really fast. Synthetic substitution, I still have to deal with bigger numbers as I go, but I only had to multiply by 3 and then add, multiply by 3 and then add, multiply by 3 and then add. I can multiply by 3 pretty well. Even if I get to a number that I'm not sure immediately, I can sketch off to the side 216 times 3 or whatever I needed to. So it goes a little bit quicker. Now, this next little piece, this is the behind the scenes of why this works. This is a hideous looking thing to look at, but it's what happened. So let's dive in a little bit. 3 times 3 minus 1. 3 times 3 is 9 plus negative 1. Okay. Then I have plus 0. Then I'm multiplying that by 3. Oh, I got ahead of myself. This times 3 gets me that 24. Then I add 0. Right? That's getting here. I'm going to multiply that by 3. And then I add 0. And multiply that answer by 3. And this time I have to add that negative 5. That's how I get to this piece. Then I multiply that by 3 again. Then I add my 10. So I'm still doing all of these pieces. I'm going to erase these highlighter marks because if you look at this after the fact, those highlighters are going to be really confusing. But you're doing everything that you're supposed to do as if you had gone through a very complicated factoring process. Synthetic division is just a nicer packaging for a really weird behind-the-scenes product. Because here you've got 1, 2, 3, 4 different sets of parentheses all inside of each other, which is kind of insane. So you are going to need to know how to do both. You should already know how to do direct substitution. You're going to save yourself a world of time in this chapter if you can do synthetic substitution. Have a great day, everybody.